interesting. Very interesting. I like hearing what people think. So what we're gonna do next is I'm gonna do one more poll. One more poll here. This one will be a little bit more, even bigger picture than the one we just saw. So instead of sending people to Mars, what I want you to think of is, when do you think is a realistic timeline for people to send where did we go? Here we go. What do you think is a realistic timeline for the first human to travel to the closest solar system? Actually, no. Oh, no, no, no. We'll do that later. We'll do that later. I messed up there. I realized I moved things around. We will look at that question. We will look at that question though. When do we think we're going to send people to other solar systems? So what we're going to do today is we're going to be looking at a lot of like rocket science. We're looking at a lot of space travel. So we're going to be looking at some cool stuff. So to help you go along with today's lesson, there is oh, that's the Zoom one. What am I doing? I'm sorry, that's the Zoom link. Um, okay. Here's the Google Doc. So what I want you to do is I want you to fill out the graphic organizer that I just linked, that you're gonna fill along as we're going along this. And then you can turn it in when we're done. So I think this will take 2 days. So we'll work on it today and Friday. Um, it's also on campus, so if you want to go along there as well. So yeah. So as you're opening this, what I'm going to do is I'm going to start talking about the first thing we're going to discuss. So in the 1970s, so in the 1960s, I believe we had 6 successful missions to the moon. I believe we sent 6 groups of astronauts. And then in the 1970s, NASA had a plan to send humans to Mars. So they actually had a plan to send humans to Mars. And if you ask what most people thought in the 1960s and 1970s, they would say that they expected to send humans to Mars by 2000. So they would have said by the turn of the 21st century, we expect to send humans to Mars. However, it's been 50 years since 1970, and 50 years later, we haven't really sent any humans to Mars, and we are still quite a ways from doing that. So what I want you to do is I'm going to send you to your groups, and I want you to discuss some of the obstacles that you think may have prevented a human mission to Mars. So in your group, I want you to talk about what are at least 3 major challenges that NASA has to overcome in order to send people to Mars. So I want you to come up with at least 3 major challenges, and then afterwards, I want you to be prepared to share in the chat what your group came up with in terms of 3 major challenges that NASA has to overcome. So once again, I'm going to put you in your groups, and I want you to discuss some of the obstacles that may have prevented a human mission to Mars. I want you to come up with at least 3 major challenges that NASA has to overcome in order to send people to Mars. So I am going to put you in your groups now. And then when we come back, I want you and your group to have 3 different challenges that NASA has to overcome.
Okay, so what I want you guys to do is I want you guys to take 2 minutes in the chat. I want you guys to start typing in some of the challenges that your group came up with. And around 10:31, I'm going to tell you to hit enter, and I want to see a bunch of challenges that you think NASA has to overcome. So I want to see a lot of ideas from people. We gotta brainstorm here. What to think of what are some ideas that are preventing us from sending stuff to Mars. So take about a minute and a half, 2 minutes to type in your group's ideas or challenges that NASA has to overcome. And then in about a minute or so, we'll see what everyone has to say. Take it on another 30 seconds or so. 30 seconds. What are some challenges that your group came up with? What are some things preventing us from sending people to Mars? Why haven't we done it already? We sent people to the moon. We sent rovers to Mars. Why haven't we sent people to Mars yet? It'll take 10 more seconds. 5, 4, 3, 2, 1. Hit enter, hit enter, hit enter. Let's get some ideas. Let's get some ideas going. Let's get some ideas going. Ooh, we got a lot of ideas here. That's really good. I'm really impressed. I didn't get a whole lot of ideas in fifth period, so I'm really glad we've got a lot. Let's get some more ideas here. Get some more ideas. We got a bunch of them. I'm gonna start reading off some of them that are on some of the ones. So missing some numbers calculations. Yeah. So people have made a lot of it. So one time NASA had a big issue with what they were sending something to. It was like they're sending a rocket up in space, and what the issue they made was that instead of using meters, which is usually there's a reason why we measure things in units and meters is because it's the standard unit of measurement for engineering and for physics. But NASA was using things in freedom units, so inches, feet, and stuff. And so when you are meant to do calculations in meters, but you're doing it in inches and feet, that's a problem. And so I think the rocket was very disastrous because they did their math wrong. So that's why I try to stress units as much as possible, because if you mix up units and someone else is using your math, right, their rocket could blow up. So it's very important to keep units the same. So missing some numbers can definitely be a huge issue. We got a lot of ideas here. So
That
not
was
enough
the
air.
Government Space Agency, and they forgot meters.
Yes, you would think that if you were a
Man.
government space agency and you are very smart, that you would not forget use meters. But I'm serious. It's like it's very easy for anybody to make that mistake of not using meters. So if you think that you're the only person who's making that mistake, I just want you to know there are real NASA scientists who made that same mistake, and it has huge consequences because your rocket could blow up. So that's a huge issue. So make sure you're using the right units here. That's really important. That's why I try to stress it a lot. Here are some other ideas. So not enough air, little to no resources such as water or trees, extremely difficult and expensive to even send robots or researchers to Mars. There's also no guarantee that the items will be delivered and in one piece. Good, 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 good. I want to read everyone else's before I talk about some of these ideas in more detail. Maintaining resources, radiation, good, good. Food, water, returning to Earth. Yeah, believe it or not, we want to send astronauts back to Earth. Food, fuel, people, possibility of becoming autonomous from Earth. That is interesting. Aliens living beneath the surface, asteroids and navigation, landing. The moon landing was faked or something. So the moon landing was real. So we definitely did send people to the moon. But there is a very big difference between sending people to the moon and to the Mars versus sending people to Mars. So there is a lot of challenges there. Would be hard to supply the astronauts with enough food, water, and oxygen to be able to make it to Mars and back. Exactly resources, getting them there, not enough oxygen, creating a stable ecosystem on the planet. So that is really interesting. Creating a stable ecosystem on the planet is going to be very challenging. If you've ever watched the Martian, it was a challenge for Matt Damon to try to grow potatoes on the planet. Now, luckily, if we're just sending a person to Mars, we don't necessarily like creating a stable ecosystem. But if we want to create, a settlement in Mars, we do need to try to create a stable ecosystem. And I can tell you right now, that's going to be a huge challenge. Resources, landing difficulty, fuel, food, water supplements, not enough oxygen resources in general, food, water, etc. Oxygen control, having the right amount of oxygen, gravity. Okay, so a lot of people have talked about oxygen. So let's talk about why oxygen is such a huge deal. We obviously need to have a lot of oxygen. The problem with Mars is Mars has a very thin atmosphere, which means that there's not a lot of oxygen there. So just like if you go to the moon, you need to have a spacesuit with oxygen. The same thing occurs for Mars. You need to have a lot of space. You need to have the spacesuit with a lot of oxygen. But the problem is, right, you need a lot of oxygen, and it's a very long trip. Additionally, because it's a very long trip, food, water, and stuff actually become a huge issue. Like if you're sending someone to the moon, right, you don't actually need a whole lot of food or water because it's almost like a day trip, right? You don't like if you're going on a day camping trip, like you could honestly not survive without not a lot of food or water. But if you're on a month-long trip, or a year-long trip, right, you're gonna need a lot of food and water, and that's gonna be an issue because you got to find a way to send it there. So that's also very challenging. So I like all the ideas that you guys have shared. So we will talk about some of these ideas more in depth today. So beyond just the challenges of sending things to Mars, what I also want you to look at is probably the first challenge that I think some people have sort of talked about a little bit. The first challenge is that Mars is really, 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 really far away. And the question is, how far away is Mars exactly? So what I want you to do is I'm going to put you in your groups, and I want you to Google how far Mars is from Earth, and I want you to record a distance in your graphic organizer. Now, here's the thing. When you Google how far is Mars from Earth, Google will give you a big fat number. Do not write that number down because it's a lot more complicated than just writing a number from Google. I want you to read through at least one or two articles, and I want you to learn about why is it so more complicated than it seems. So go through a couple of articles here, try to figure out why is it. Try to go through a couple of articles and then try to and ultimately come up with a number for how far Mars is from Earth. Again, it's a lot more complicated than just Googling something. You'll have to read a little bit. So I think that the first, if you Google how far Mars is from Earth, the first one or two articles on Google are pretty good, and they can give you an idea of why it's a lot more challenging than what it seems. So I'm going to give you maybe about 5 minutes or so to try to come up with a distance for how far Mars is from Earth. So let's talk about why it's so complicated. So if you just Googled how far Earth is from Mars, you probably got something, a number like 168 million or something. But the reason why I said that I want you to know, look at it more is because what's happening is that Earth and Mars, they're both revolving around the sun, but they have different orbits. So they're orbiting around the sun at different speeds. So sometimes they can be really close to each other, and sometimes Earth and Mars can be on opposite sides of the sun. So the distance between the two are constantly changing. So if you just pick the number that Google tells you, you don't actually know what that distance is measuring. Are we measuring the distance between when they're closest, or are we measuring the distance from when they're the farthest? So it's not really an accurate number. So just saying that that it's 168 million doesn't really tell us the whole story. So that's the reason why Earth distance from Earth to Mars is so complicated, is because, well, both are revolving around the sun and they have different orbits and they're revolving at different speeds. So they're not always going to be the same distance away from each other. So that's sort of the gist of why one of the challenges that Mars is really far away. To sort of give you an idea of what this means in terms of the practicality of it is, I want you to take that distance. So the distance we're going to use here is we're going to use the distance 168 million. Oh, you guys can't even see my slides. Ah, that's annoying. Okay, so what we're going to use, we're just going to use the number that Google gave us, which I think was 168 million or something. And what I want you to do is I want you to figure out how long does it take for a rocket that goes 24,000. I want you to figure out how long does it take for a rocket. So the rocket that NASA currently is designing is the SLS, the Space Launch System. So that's the big new rocket they're designing, and that has a speed of 24,500 miles per hour. So what I want you to do is I want you to take that speed and I want you to figure out how long does it take for a rocket that's traveling 24,500 miles an hour. How long does it take for that rocket to travel the distance from Earth to Mars, which is 168 million miles? So in this particular model, Earth and Mars are both stationary and the rocket goes from Earth to Mars. So I want you to figure out how long does it take for the rocket to go from Earth to Mars. And yeah, so I just also want you to be very careful with the units. So just make sure you know what that time is. The next thing I also want you, once you finish to figure out how long it takes to go from Earth to Mars, I want you to discuss the limitations and drawbacks of using this model. So this model is modeling both Earth and Mars as being stationary. So they're both stationary, they're both not moving. So what I want you to do is I want you to look at the limitations of this model and what does this model not account for. So I'm going to give you maybe around 5 to 10 minutes to do so. So figure out how long it takes, and then I want you to figure out what are some limitations and drawbacks of using this model. So I'm going to put you in your groups again, and then to come up with how long does it take to go from Earth to Mars, and what are the limitations of using this stationary model. So let's take a look at this. Let's see if we can figure out how long it takes. So we're using the distance from the Google distance that Google gave us, which is the 168 million miles. And we want to figure out how long does it take for a rocket to go from Earth to Mars. So what we're going to do is we're going to take our distance here, which is at 168 million, and we're going to divide it by our speed. Right? We're basically trying to figure out how many hours does it take for us to go. If we're traveling 24,500 miles an hour, how many hours does it take to go this distance? And this will give us a time. And if we do the math here, what we get is our time is something like 66,800 or something hours, and something like that. Now, for me personally, hours isn't the best way to measuring time because it doesn't make a whole lot of sense to me. So what I'm going to do is I'm going to convert this to days, and we get something like 285 days. So what this means is that using this rocket technology, it's going to take roughly 9 to 10 months to go from Earth to Mars, which is a pretty long time. And if we're thinking about round trip, we're talking about a year and a half, close to 2 years worth of travel time. That's a long time. Now, one of the things that we made a very gross simplification when we assumed that Earth and Mars are both stationary. We're just saying, okay, Earth is point A, Mars is point B, and the distance between the two is 168 million miles. And so just figure out how long it takes. But that's a very gross simplification. That's what we call, assuming that both are the stationary, we call that a model. And a model is just basically saying a way of setting up a scenario. However, in this particular model, though, it's not very accurate because we're assuming that Earth and Mars are both stationary. The problem with this is that in this model doesn't account for the fact that in reality, Earth and Mars are both rotating around the sun. And so the distance between the two are constantly changing. So the travel time that we have now may not be what the real travel time is because the trajectories are always changing. So you can't just launch a rocket from Earth to Mars and just hope that it sticks. The trajectory is always changing, and so you're gonna have to make adjustments for that. So that's the problem with using the stationary model is it's not really accounting for the rotations of Earth and Mars around the sun. So yeah, so that's pretty much, give you an idea of some of the challenges of sending people to Mars is. What I want you to do now is I want you to think about, do you think it's harder to accelerate from 0 to 50? Or do you think it's harder to accelerate from 50 to 100? So I'm going to give you guys a few minutes to think about this. I'm going to put you in your groups, and I want you to think about, is it harder for something to accelerate from 0 to 50? Or do you think it's harder for something to accelerate from 50 to 100? Or do you think it's the same? So I'm going to put you in your groups again, and then let's see if we can get some ideas as in terms of, is it harder, when is it harder to accelerate from 0 to 50, or is it harder to accelerate from 50 to 100?
You're muted.
He's probably talking to Candy.
Yeah, I'm sorry, I'm muted. Yeah, I know. Sorry. Okay, so we're out of time here. So I think we're right on pace. So we're gonna finish the second part of this, I think, on Friday. You no homework or anything. I really like what you guys. I get used to having a bell again. I like what you guys said about all about why it's difficult to go from Earth to Mars. So we're gonna pick this up on Friday, and then I'll see you guys then. No homework. Yeah, have a good one.
Thank you.
Thank you, Mr. Yu.
Thank you.
Bye. Thank you.